Okay, so let's talk a little bit about compound interest. Exponential growth and decay also have to deal with compound interest. So if you ever get a credit card or a car loan or a mortgage or you borrow money to pay for college, you are going to have to deal with the effects of compound interest. Okay, there's interest on the loans that you don't pay back right away. That's just the way life works. And this is how you can investigate how much money you're going to spend on interest when you take out a loan for a car or for college or home. Okay, this is how it is calculated. So this is directly applicable to your life. Okay, so when are you ever going to use this? When you borrow money for a house, when you borrow money for a car. All of that stuff uses compound interest, okay? And here's how they figure it out. Okay, well, first of all, compound interest occurs when interest is calculated on both the principal amount and the accrued interest thus far. Principal amount is the initial amount, the amount you borrowed for a house, the amount you paid for a car, stuff like that. Okay, so here's the formula for how they figure it out. It's A equals P times 1 plus R divided by N to the power of N times T. That's a lot. Don't worry, we're going to break it down, okay? A is your final amount, your amount you get once you calculate your accrued interest, okay? P is your principal, which is another fancy way of saying initial amount. Whenever you buy a house or a car, they'll refer to principal. Okay, that's the amount you borrowed. R is your rate. N is the number of times compounded. And the way they calculate interest is they count the number of times compounded yearly. Okay, compounded yearly. Can you see that? There it is. And then T is time. T is always time. Okay? So let's do a few examples. We're going to do 2 together, and then we'll do 3 in class. I'm going to try something different this time, see if this works out better. So we're going to do 5 and 6 together, and then you can try 7, 8, and 9 before you come to class, and then we'll go through them together as a class. Okay? So let's do number 5. Laura deposited $12,000 into an account that earns 8% interest. So $12,000, 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? Okay, so here we go. Let's set up our function or our formula. It's A equals, our principal initial amount is $12,000 times 1 plus our rate is 8% interest. Again, we want that as a decimal, so 0.08 divided by. So N is the number of times compounded yearly. Well, it says quarterly. Quarterly means 4 times a year, so our N is going to be 4. Okay? To the N times T. Well, N is 4 and 5 years is T, so 4 times 5. Whew. Okay, let's see if we can't simplify this a little bit. A equals 12,000 times, let's see if we can figure out what all of this mess turns into. So we have 1 plus, I'm going to use parentheses to separate here, 0.08 divided by 4, 1.02. So all of that stuff in the parentheses turned into 1.02, and then 4 times 5 is 20. So let's plug that in the calculator and see what we get. 12,000 times 1.02 raised to the power of 20. And you get $17,831.37. So $17,831.37. We're talking about money, so we're going to put our dollar sign. We'll do one more together, and then we'll save the 3, 7, 8, and 9 for our classwork together. So Jack took out a 6-year loan, so 6 years looks important, for $25,000 to purchase a boat at 4.5% interest rate. If the interest is compounded monthly, what will he have paid total over the course of the loan? Okay, so here we go. We have A equals, our principal amount is $25,000 times 1 plus, our rate is 4.5% interest, but we want that as a decimal, so it's 0.045 Monthly, well, how many months are in a year? 12, so our n is 12. It's probably a bad place to put that, but okay. To the power of, yeah, I ran out of room. This is to the power of 12 times 6, because that's a 6-year loan. Okay, so let's simplify this a little bit. 25,000. Let's figure out what this turns into. 1 plus 0.045 divided by 12. 1.00375 to the power of, well, 12 times 6 is 72. Okay, now we just plug that in our calculator. Okay, 25,000 times 1.00375 to the power of 72. $32,732.58. So we have $32,732.58. Okay, and that's compound interest. And like I said, we're going to go through the next 3 together in class, but please try them beforehand. Okay, try them on your own, bring them to class, ask me questions. All right, that's concept 1.